to cover 4.1 matrices. Okay, and we are going to accomplish these 3 learning outcomes. Alright, so the first learning outcome is to identify the different types of matrices. Okay, so if you can see this summary here, so yeah, the types of matrices are listed down here. Okay, so now let's go through each of these matrices. Yeah. Okay, so the first type of matrix is row matrix. Okay, so what is a row matrix? So row matrix is a matrix with single row only. Okay, so it can have as many columns as possible. Okay, but then it will only have one single row. Okay, so if you can see example here, so we have one row matrix here, which means okay, we can say that the order or the dimension is 1 by 3 matrix. Okay, so in order to mention or to pronounce the dimension of the matrix, so it has to be okay, started with the row followed by column. So like this one, okay, the row matrix here is 1 by 3, okay, dimension. Then let's see the second one, okay, column matrix. So we do have okay, a matrix which has only one single column. So again, it can be okay, it can have as many rows as possible. Okay, but then it will have only one single column. So like this one, so we can say that this matrix is a column matrix, and the order or the dimension is 3 by 1 matrix. Okay, so again we pronounce the row first followed by the column. Okay, then what about zero matrix? Zero matrix is a matrix which has all elements to be zeros. Okay, so you can have any order. Okay, it can be 2 by 2 or even 2 by 3 and so on. So as long as all the elements are zeros, so we can say that the matrix is a zero matrix. Okay, then next, what is a square matrix? Okay, before we discuss diagonal matrix, so let's discuss square matrix. Square matrix is a matrix which has the same number of rows and columns. Okay, so for example, if it has 2 rows, so it will also have 2 columns. Okay, equal number of rows and columns. So we can have, okay, so this is an example of 2 by 2 matrix, and this one also 3 by 3 matrix. So we can say that these two are okay, type of square matrices. Alright, and yeah, if you have 4 by 4 also, we can call it as square matrix. Okay, but then let's say if you have a matrix which is 2 by 3 or 3 by 2, so it is not a square matrix because the number of columns is not equal to the number of rows. Okay, then next, what about diagonal matrix? So diagonal matrix is a square matrix. Okay, so square matrix, again we recall the same number of row and column. So diagonal matrix is a square matrix in which all of diagonal entries are zeros. Okay, so what is diagonal? So diagonal is this. Okay, so we join the corner of this matrix and this corner. So this is what we call as the diagonal elements. Okay, so the number here in the diagonal part, so 1, 2, 3. So those are the elements in the diagonal entries. Okay, so diagonal matrix is a square matrix in which all off diagonal entries are zeros. So off diagonal means okay, apart from the diagonal elements, so the elements will be zeros. So that is what it meant by diagonal matrix. Okay, next, what is upper triangular matrix? So upper triangular matrix is a matrix which all its entries below the diagonal are zeros. So again, so we can say here, these are all the diagonal elements. So below the diagonal are zeros. So okay, you can see the name here, upper triangular matrix means okay, all the elements in the upper triangular part will be not zero. Okay, so we do have elements okay in the upper triangular part. Okay, so again the opposite of it is the lower triangular matrix. So lower triangular means we have all the element in the lower triangular part. Okay, so all its entries above the diagonal are zeros. So we can say that this is the diagonal elements. So above the diagonal, so we have all 0 elements. Okay, and lastly, identity matrix. Okay, what is identity matrix? So again, identity matrix is a square matrix. okay, which has same row and column, okay, and it has ones along the main diagonal and zeros for all other entries. Okay, so we can say that identity matrix is also a diagonal matrix. So by recalling the definition of diagonal matrix, okay, so we do have the element in the main diagonal part here, okay, to be not zero, and then the rest of it will be zeros. So that is identity matrix. Okay, how to perform operations on matrices. Okay, so let's see here, operations of matrices. We do have 4 different operations, okay, just like real numbers. We do have addition, subtraction, multiplication, okay, but then special case on matrices is that we don't have division of matrix. Okay, so now let's see example. So okay, if we have addition, okay, so how to add the 2 matrices. So I will give you 2 by 2 matrices to be the example. So let's see if we have 1 2 3 4. Okay, this is 2 by 2 matrix. Alright, and then plus with, so the same 2 by 2, it has to be same order in order to perform addition and subtraction. So let's say if you have 4 5 6 7, okay, then how to perform addition. So we just add the entries, okay, the same entries. Okay, for example, this is element in the first row, first column, so we add with this, okay, this element in the first row and first column of the second matrix. So we will have the answer 5. Okay, and then next we have this element in the first row and second column, so we add with, okay, this also element in the first row and second column of the second matrix, so we will have 7 here. Okay, then if we have this 3, okay, the element in the second row first column, so we are going to add with this element in also the first row and first column of second row and first column, so we have 9 here. And next one, we have this element in the second row and second column, so we add with this element in the second row and second column, so we will have 11. Okay, so this is how to perform addition. So if you need to perform subtraction also, so it's going to be the same. Okay, so now I'm going to change this to minus, okay, and we get rid of all the elements here. Okay, we're going to change this to subtraction. Okay, so how to subtract this? Okay, so we change it to subtraction. So again, we do the same. Okay, so let's say here 1 minus 4 will give us negative 3, and then 2 minus 5 will give us negative 3, and then 3 minus 6 will give us negative 3. Okay, then 4 minus 7 will also give us negative 3. Okay, and then next, how to perform scalar multiplication. Okay, scalar multiplication means if you have a scalar multiplied by a matrix, okay, then what we're going to do, we're going to multiply each and every element in the matrix with the scalar outside. So for example, if we have scalar 5 here multiplied by this matrix, so we will multiply each of the elements. So let's say here we have 5 times 1 5, 5 times 2 10, 5 times 3 50, and lastly 5 times 4 20. Okay, so that is how we perform scalar multiplication. Alright, and then now when it comes to multiplication between two matrices, okay, so let's say if we have multiplication, so okay, if we have this 1 2 3 and 4, okay, let's say we multiply with this matrix, okay, 6 7 8 and 9. Okay, what we're going to do, we are going to multiply these two matrices, and the operation will be, okay, we will multiply the row of the first matrix with the column of the second matrix. Okay, so here we are going to multiply this 1 and 2 with 6 and 8. Okay, so the result will be 1 times 6 plus 2 times 8. Okay, so that is the first row of the first matrix multiplied by the first column of the second matrix. Okay, then next, okay, we do have this first row multiplied by the second column of this matrix. So we will have 1 times 7 plus 2 times 9. Okay, so then next we will get the second row of the first matrix multiplied by the first column of the second matrix. So we will have 3 times 6 plus 4 times 8. Okay, and then lastly we have this second row, okay, of the first matrix multiplied by the second column of the second matrix. So we will have 3 times 7 plus 4 times 9. Okay, and then we put the bracket here. So then, okay, we just press calculator to get the answer. So now 6 plus 16 will give us 22, 7 plus 18 will give us 25, 18 plus 32 will give us 50, and lastly 21 plus 36 will give us 57. Okay, so this is the answer to this matrix multiplication. Okay, now the last learning outcome is to find transpose of a matrix. Okay, and we need to include the properties as well. So here we do have the properties of transpose matrices listed. So there are 4 different properties here. Okay, but then first, what is transpose matrix? Okay, so transposition of a matrix is actually we change the row of the matrix to be the column. Okay, so let's see an example. Okay, how to transpose a matrix. Okay, let's see if we have example 1, 2, 3, 4 here. So we have 2 by 2 matrix here, and we need to transpose this matrix. So what will happen is that, okay, so we can see that this is the first row of this matrix, right? Okay, so we are going to get these 2 elements to be the first column of the matrix. Okay, then here if we do have the second row of this matrix, so it will become the second column of this matrix. Okay, so this would be the answer. So transpose is basically we change the row to be the column of the new matrix. Okay, so in order to see the example, more example on this, we are going to solve a past year question. Okay, question number 1. Okay, so how to do this? So let's discuss. Okay, this past year question number 1. Okay, so we are given 3 matrices A, B and C. So we can see here A is 3 by 3 matrix. Okay, while this B is 3 by 2 matrix, and then the C is 2 by 3 matrix. Okay, so now how are we going to solve this question? So find matrix D, okay, such that A is equal to B times C transpose. Okay, so what we're going to do here, we are going to multiply matrix B and C first. So B times C will be, okay, we list down. So we have 1, -1, 2, -1, 0, -1. Okay, so this is 3 by 2 matrix multiplied by C. So C is 2 by 3. So we have 2, -1, 0, 3, 0, -1. Okay, so if we have this matrix multiplication, so let's say here the order of B is 3 by 2 and the order of C is 2 by 3. So, okay, now since the number of column for matrix B is equal to the number of row, okay, in matrix C, so that means the matrix multiplication is possible, and then we expect to have the result to be 3 by 3 matrix. Okay, so now let's do this. So again, matrix multiplication is by multiplying the first, okay, the rows of the first matrix by columns of the second matrix. Okay, so what does it mean? So let's see here. We're going to multiply the row with this column. Okay, so let's do one by one. So we do have, okay, so 1, okay, so this row multiplied by this column. So we will have 1 times 2 plus -1 times 3. Okay, so Then next we will have this first row multiplied by the second column. So we will have 1 times -1 plus -1 times 0. Okay, and next we will have the first row multiplied by the third column. So we will have 1 times 0 plus -1 times -1. Okay, and we close the bracket here because it's a matrix. Okay, then next, okay, we're going to multiply this second row with the first column here. So we will have -1 times 2 plus 0 times 3, and then okay, the second row multiplied by second column. So we will have -1 times -1 plus 0 times 0, and then we will have this row multiplied by this column. So we will have -1 times 0 plus 0 times -1. Okay, and we do the same also for this third row, and we multiply by the first column here. It's 2 times 2 plus -1 times 3. Okay, and this third row multiplied by second column. So we have 2 times -1 plus -1 times 0, and then lastly we have this third row multiplied by third column. So we will have 2 times 0 plus -1 times -1. Okay, now then it's just about simplifying the answer. So we have 2 minus 3 is -1. Okay, so -1 here, and then -1 plus 0 is -1, and then we have 1, so -2 here, and we have 1 here, and then we have 0 here. Then 4 minus 3 will give us 1, -2 plus 0 will give us -2, and 0 plus 1 is 1. Okay, so this is the BC. Okay, then in the question we have BC transpose. Okay, so how to do that? So again, transposition of a matrix is by changing the column to be the row or the row to be the column. So now how to do BC transpose? Okay, so that means we have to transpose this matrix. Okay, so what do we do? Okay, we get the first row here, -1, -1, 1, -1, -1, and 1. Okay, so that will become the first column. And then we take the second row here, -2, 1, and 0, and then lastly 1, -2, and 1. Okay, so this is BC transpose. Okay, after we get this, then how to find D? So D is basically A minus BC transpose. Okay, so D, new matrix, is A minus BC transpose. So which means, okay, we bring down the A matrix. So it's given here. So we will have -1, 0, and -2, 2, 1, 0, -1, 1, 0, minus with the previous matrix that we get here. Okay, so we have -1, -2, and 1, -1, 1, and -2, 1, 0, and 1. Okay, now performing the subtraction. So we will have -1 minus -1 means we will have -1 plus 1, which is 0, and then 0 minus -2, okay, so 0 plus 2, and then -2 minus with 1, so it's -3. Okay, now 2 minus -1, 2 plus 1, 3, and then 1 minus 1, which means 0, so 0 minus -2 is 0 plus 2, and then -1 minus 1 is -2, and then 1 minus 0 is 1, and 0 minus 1 is -1. Okay, so this is basically the answer.